Using the properties of 1. Okay, we have to talk about the number 1 now, because it's about to make our lives a lot easier when working with rational expressions. 1 is an absolutely great number in mathematics, and it's really useful in algebra and mathematical problem solving, including in math and science, because when you multiply by 1, nothing changes. So you have no net effect on something when you multiply on 1. 10 times 1 is 10. 1 times negative 12 is negative 12. So let's just look at 1 for a second. 1, we can write that as 1 over 1. It's the same as 2 over 2. It's the same as 3 over 3, or x over x, as long as x isn't 0, because you're not allowed to divide by 0. So if we have a number like 5 over 6, we can change what 5 over 6 looks like by multiplying it by 1 over 1. I can multiply by 1 on top, by 1 on the bottom, or instead of that, I could multiply by, as we've seen, 2 over 2, because 2 over 2 is just equal to 1. So multiply by 2 over 2. Nothing about this fraction changes. It looks a little different, but 10 over 12 is an equivalent expression to 5 over 6. They're numerically exactly the same, even though they look a little bit different. They represent the same number. So we're going to use this power of 1 to make our rational expressions look a little bit different without actually doing any illegal mathematics. Here's an example. We have this complex fraction. Before, we taught you that we could add the numerator fraction together, add the fractions in the denominator together, or subtract them, and then flip and multiply. But I'm going to show you something that makes our lives a lot easier. I'm going to use the power of 1. I'm going to multiply this top fraction by 6, and I'm going to multiply this bottom fraction by 6. So I'm multiplying by 1 because I'm multiplying by 6 over 6. And so what this does is, I'm going to multiply 6 into this bracket. Well, 6 times 1/3 is 6 over 3, which is 2. And 6 times 1 over 6 is 6 over 6, which is 1. My numerator has just been completely eradicated of fractions. In the denominator, if I do the same thing, 6 times 1/2, I get 3, and 6 times 1/3, I get minus 2. And look at that. Just by multiplying by 1, I have reduced my complex fraction into a very simple looking fraction, which simplifies all the way down to 3. Now, isn't that a lot easier than the method we did before, where we used division? This tool is going to come in very handy with complex expressions. Now, how did I choose 6? I chose 6 because it was the smallest number that would eliminate all these denominators. 6 is the lowest common multiple of 2, 3, and 6. So I didn't just pull 6 out of thin air. I picked 6 because it was going to eliminate, by multiplying the top and bottom by 6, it was going to eliminate every single denominator in those fractions. So how can we use this to simplify this complex fraction that we actually saw in the previous skill? How are we going to do it? Well, looking at this top fraction and looking at this bottom fraction, I'm going to multiply by 1. So let me pick a different color here. I'm going to multiply by 1, which is something that will eliminate the of the fractions in this problem? Well, the denominators have x, y, y, x. So the smallest thing I can multiply by, the simplest thing I can multiply that will eliminate each fraction is if I multiply by x times y on the top and x times y in the denominator. So that's 1. xy over xy is 1. And now I'm going to multiply this in. So I have 1 over x plus 1 over y times xy over x over y minus y over x times xy. And watch what happens as I multiply it in. So as I multiply xy times x, the x's cancel and I'm left with just y. When I multiply xy times 1 over y, the y's cancel and I'm left with just x. In the denominator, I multiply xy over there, the y's cancel and I'm left with x times x, which is x squared. And I have minus, well, x times y times y over x, the x's cancel and I'm left with y squared. And now I can simplify this. I'm going to rewrite the order of the numerator and factor with difference of squares in the denominator and cancel. And you saw how much more work it took to solve this problem using division and our flip and multiply strategy. But if we are comfortable using this property of 1, multiplying the top fraction and the bottom fraction by the same thing can eliminate all those denominators in the problem, making our lives a lot easier. Here's another example. And so in order to figure out what I need to multiply by, first I have to factor anything that's factorable. So I have that 2 over x plus 6 on the top fraction. In the bottom I have 4 over x minus 6 minus 4, and this is the difference of squares, so it'll be x minus 6 times x plus 6. What do I need to multiply these fractions by in order to get rid of the denominators in the top and bottom? I need to multiply by x minus 6 times x plus 6, because that will eliminate the fraction in this one, and it will also eliminate the fraction in these other two. So you're looking for basically the simplest thing that you can multiply that will cancel all those fractions, and it's going to leave us with some leftovers, but that's okay because they'll all the fractions will be gone, which will mean our lives are a lot easier. So I have to multiply the bottom by x minus 6 over x plus 6, so I have to multiply the top by x minus 6 over x plus 6. And now I multiply this to each, the numerator and the denominator. So I have 2 over x plus 6, and I'm multiplying it by x minus 6 over x plus 6. That's my numerator. We can see right away what's going to happen, which is that my x plus 6 and my x plus 6 are going to cancel. In the denominator, it's really important here to follow the process, which is that you have to multiply this x minus 6 times x plus 6 into each term in the denominator. So I have 4 over x minus 6 times x minus 6 times x plus 6, and then also 4 over x minus 6 times x plus 6 times x minus 6 times x plus 6. Because you have to multiply it into each term in the denominator. And now I can go ahead and cancel whatever will cancel. So x minus 6, and both terms in the denominator cancel of that next fraction. And this is going to simplify really nicely. 2 times on the top, I have 2 times x minus 6 is 2x minus 12. And in the denominator, actually, you know what? I'm actually not going to multiply that in yet. I'm just going to write it as 2 times x minus 6 because I might get some more cancellation before all of this is done. So that's my numerator. In the denominator, I have 4 times x plus 6 minus 4. And now doesn't that look a lot nicer than what we had before? And so I'm going to continue to simplify. So not going to touch my numerator just yet, but I am going to expand my denominator, which is going to give me 2 times x minus 6 over 4x plus 24 minus 4 is 4x plus 20, which can be simplified 2 times x minus 6 over factor out of 4 would be x plus 5. And a little bit of canceling happens. 2 and the 4 cancel out a bit. So I get x minus 6 over 2x plus 5. So wasn't that a lot easier than going through combining those denominators together and then flipping and multiplying? I think that this just ends up saving a ton of time. One last example. This is an interesting one. So I have y over y plus 1 over 1 plus 1 over y minus 1. What do I have to multiply by? Looks like it's going to have to be y plus 1, because that will eliminate this denominator here. And I also have to eliminate this denominator on the bottom, so I have to multiply by y minus 1 as well. So I'm just sort of piecing together what I have to multiply each side of the fraction by. And now I can multiply that in. So I'm going to multiply those guys in the numerator together. So multiplying that guy over, I get y over y plus 1 times y plus 1 times y minus 1 over, and multiplying this guy, I've got to multiply it to the 1, and I've got to multiply it to the fraction 1 over y minus 1. So that would be 1 times y plus 1 times y minus 1, and then plus 1 over y minus 1 times y plus 1 times y minus 1. So you're probably seeing the cancellation that's happening before as I'm writing this out. And so when you start to get comfortable with these types of questions, you'll be able to start doing the canceling sort of in the intermediate steps. It's just that I don't recommend it until you're really comfortable with the mathematics and you've done some examples showing all your steps, because it's really easy to make mistakes in these problems. So in the numerator, I have y times y minus 1. In the denominator, I have y plus 1 times y minus 1 plus y plus 1. And now I've got to just simplify as much as I can. So expanding this out, I get y squared minus y plus y, those cancel, minus 1 plus y plus 1. So those y's cancel, those 1's cancel, and so I have y over y minus 1 over y squared plus y. So I'm going to factor the bottom to be y times y plus 1. Y's cancel, and I'm left with y minus 1 over y plus 1.